Hello everyone, myself Vikas here studying in SPCA Bangalore. Today I am going to discuss about the topic in theory of computations and decidability, a language that is not recursively enumerable. And decidability, a language that is not recursively enumerable. In a real computer science mathematical logic, a concept of undecidability is a profound lightning topic. That it refers to the existence of a certain language or sets of strings that cannot be recognized any recursive enumerable algorithm. Turing machine, exploring the nature and ability, provides deep insights into limits of computation and fundamental questions that defines field of theoretical computer science. What is recursive enumerability? Recursive enumerability, a set of strings said to be recursively enumerable. It can be generated by Turing machine or an algorithm systematically lists all strings in the set. This means the set can be effectively enumerated or listed by a computer program. Decidable sets. A set is considered a decidable if there exists a Turing machine that can determine whether a given string belongs to the set or not. Decidable sets are a subset of recursively enumerable sets. They can be recognized by halting algorithm. Undecidable sets. Undecidable sets are those that cannot be recognized by any Turing machine or algorithm. These sets not recursively enumerable as they cannot be systematically listed or generated by computer program. Halting program. The halting problem is a fundamental problem in computer science that asks whether the given Turing machine will halt on the given input or run forever. The problem is known to be undecidable, meaning there is no Turing machine determine halting status of possible Turing machine and the input combinations. Proof of undecidability. The undecidability of halting problem was proven by Alban Turing in 1936. Turing proof demonstrated that his Turing machines could solve halting problem. It could also be used to construct self-referential program would be logical contradiction revealing the problem's accidentability. Implications. The undecidability of an halting problem is free-lasting implications in computer science and mathematics. It establishes fundamental limitations power of algorithms, Turing machines highlighting the existence of problems that cannot be solved in any systematic comprehensive process. Turing machines and halting problem. Turing machines are a mathematical model of computation that serve as a foundation for understanding capabilities, limitations, algorithms. They consist of a tape. It can be read and write symbols on the tape, and control unit determines the machine behavior based on current state and symbol read. The halting problem asks whether the given Turing machine will halt or run forever a given input. Turing prevents and decide halting status of all possible Turing machine input combinations as a would-be logical contradiction. Undecidability. An undecidability is an halting problem. Establish an existence of problems that cannot be solved by Turing machine of algorithm. It that reflects the fundamental limitations of computation as performed applications of the field of computer science. Proof of undecidability. Diagonal argument. The proof of an undecidability of the halting problem varies. Diagonal argument, a technique developed by a mathematician Georg Cantor. Proof involves constructing a self-referential Turing machine that leads to a logical contradiction demonstrating an impossibility of a decision procedure of halting problem. Diagonalization. A diagonal argument creates a new Turing machine that, given a description of itself input, behaves an opposite way that what hypothetical decision produced for an halting problem would predict. The self-referential structure of the key to the proof undecidability. The self-referential turning machine constructed the proof leads to a logical contradiction that cannot be description. The demonstration that the halting problem undecidable as no turning machine that consistently redetermine the halting status of all possible programs. The turning machine simulation argument. Universal turning machine, a concept of a proof and disability idea. Universal turning machine that can be simulated behavior of any other turning machines. Allows the construction self-referential program can reason about the own disciplines and behavior. Simulation argument. Turning machine simulation argument. Art of the proof and decidability. It demonstrates the turning machine could solve halting problem. It could be also a construct of a self-referential program that would be a logical contradiction. The turning machine simulation arguments reveals fundamental limitations computations, existence of an undecidable problems, the reaching implications, the field of computer science, mathematics, and nature of computability. Self-referential sentences. Self-reference sentences such as "this is a sentence" is false play a crucial role the proof of undecidability. Self-referential structure where the sentence refers to its own truth or meaning, leading to paradoxical contradiction scenarios. The logical paradoxes uses self-referential sentences in the proof of undecidability explains the paradoxical natures of such statements by constructing self-referential turning machine. The proof demonstrates the imposing decision procedure that can considerably determine halting status of all possible programs. The role of self-referential sentences in the proof of undecidability highlights the problems connections between logic, computability, and limitations formal system. This is understanding a shape development of computer science, physiological foundations of mathematics. Diagonal arguments. Diagonalization argument is presented by George Cantor, the powerful mathematical technique used to prove the undecidability of halting problems. It involves constructing a self-referential object that diagonalizes out of the given list of enumeration, leading the logical contradiction. Set theory. Diagonal arguments closely linked to foundations of set theory. Study of infinite sets countered on diagonalization provided important insights into the nature of infinity and the limitations of enumeration, laying the groundwork for the proof. Computable theory. Diagonal arguments can crucial tool the computability theory. It demonstrates the problems cannot be solved or turning machine algorithm. The proof of undecidability that had a professional impact on understanding the limits of computation. Implications of undecidability. Fundamental limitation. Undecidability of the halting problem highlights the fundamental limitations of computation formal systems. It demonstrates that our problem that cannot be solved any algorithm or turning machine, challenging our understanding capabilities of limitations of computer science. Physiological implications. The implications of undecidability extend beyond computer science, touching on physiological questions about the nature of knowledge, limits of reason, foundation of mathematics. It led to a deeper discussions about the scope of limitations of formal systems and role of institution problem solving. Practical impacts. While defining an halting problem seems abstract, it has practical impacts areas such as software verification, program language design development, and secure reliable systems. Understanding the limits of computation can be some reason most of the trustworthy software and systems. The limits of computation and decidable form problems, halting problem, discipline applications, 10th problem, limitations formal system, odd incompleteness theorems, clutch turning, these turnings, halting theorem, physiological implications, the nature of mathematical truth, limits of reason, and foundations of computation. Practical applications, software verification, programming language design, the secure system development. The study of undecidability and the limits of computation is a profound shaped understanding the nature of mathematics, computer science, the limits of human knowledge by grabbing gaining deeper insights into the fundamental nature of computation. Boundaries be accomplished through formal systematic process. The